Watermarking is simply storing a value from every execution and recalling it again the next time it is needed. It's a very important part of interfacing with another system we need to synchronize data with. A few examples of this would be keeping a record offset while pulling a third-party API, storing the latest recorded date when providing a data synchronization layer. If you're talking to Microsoft Graph, you may need to store a special encoded string called the delta link. We make working with watermarks very easy. Our watermarks are persisted locally to disk automatically and recalled on application startup. They are debounced, meaning on rapid updates, we only push the latest value on the stack. They are thread safe. You can register as many subscribers as you need to the data feed. You may push that data externally on update and recall it on initialization for further backup on a remote source. Let's take a look at watermarking within Perigee. We can do this with a few lines of code. First, we're going to register the watermark called integration offset. Our two callbacks are pretty easy. The first is to initialize if no value was previously given, and the second is an updated callback anytime the watermark is updated. On our first run, we're going to go ahead and read the current value and log it out. Given this value doesn't exist, the first value for this will be initialized to 1. Then we're going to push an update to that watermark. We're going to take the current value and increment it by 1. And finally, we're going to pull for the current value and log it back out. Let's see this in action. You can see that when Perigee started up, it said the current value for integration offset is 1, since that's what we initialized it to. And then after we pushed an update, it says the current value is now 2. I'm going to go ahead and restart this application in place. You'll see that it now says the current value is 2, and the current value is now 3, because we pushed another update to that watermark. The watermark is persisted to the disk every time that it's updated, and it's loaded every time it's requested. Let's take a look at the debouncing, as well as the additional registered handlers. Instead of pushing a single update, let's go ahead and push 10 updates all in rapid succession. And our register additional event handler call is going to log out any time that an update has been pushed through the system for a new value. Let's go ahead and see this in action. You'll see it logs out where the current value is 3, and then the next thing that we have logged out is that the integration offset is now equal to 13. The reason you did not get 10 update calls is because they are debounced, which means only updates after a small period of time are pushed. This reduces the number of calls throughout the system, as well as the need for additional read and write operations. If you're pushing the updates across the network, like to a database, this reduces the number of calls necessary for that as well.